Hey y'all, it's your main math teacher, Mr. Boyd, back at it again because today we're going to be completing the square. So what we're going to be talking about in this unit is polynomials. The most basic polynomial that we're going to be looking at is called the quadratic, and we've done that already. So we're going to be building on concepts we already understand. We've learned that quadratics come from an equation that has x squared, and they generate a parabola, which we can see here. So we're going to get a little bit of vocab before we dive in. This point here, that's kind of like that maximum point when it's a downward facing parabola, or the minimum point on an upward facing, that's called the vertex. Okay, down here we already know what this is called. That's an X intercept. But there are other words that I'm going to use to refer to it in this unit that are generally accepted. So sometimes they'll be called roots of a function, or roots of a polynomial, or zeros. Okay, so those are going to be two others, and of course we have the other one here. And then down here, we haven't talked about it at great length yet, but parabolas are symmetrical, and this line that goes down the middle is called the axis of symmetry. So what we've seen so far is we've taken our quadratic and we've done things like shift it upward, or we've had a dilation, or I think we've called it a stretch or a compression. We'd multiply it by something like that. So what we have down here is the general form ax squared plus bx plus c. Okay, a, b, and c are what's called coefficients. Oops, coefficients. And then each sort of chunk, and there are three of them here, each of those are called terms. So a quadratic can have three terms, the largest one being x squared. Okay, so what do a, b, and c do to transform it? Well, a is very similar to what we've seen in the past, okay, where we multiply by a, and that does some sort of a stretch. What about c? C down here at the end, very similar to what we've looked at already. The only difference is we've not yet looked at quadratics that have this term bx, the linear term in them. Okay, and we're not going to worry too much right now about what that does, but we do want to recognize that a is going to tell us, like for example, if a is negative, that's going to generate a downward facing parabola that's been stretched, okay? Or if this c value is negative, that's been shifted down, okay? So that'll be important to remember. What we're going to try to accomplish in today's lesson is algebraic methods for finding these zeros right here, and eventually that'll lead into finding the vertex and the axis of symmetry. So let's start with an old trick that we know well. Okay, and that would be this one. Okay, so there's an example. We're going to try to find the intercepts, and this is sort of a review from our last unit. So we remember that if we want to find an x-intercept, then all we have to do is set y equal to 0. So then we get 0 equals x squared plus 6x plus 9. Now, what I'm going to show you here is a way that's not going to work. And the reason is because it's the way that many new students, when they're just learning to solve quadratics, it's what they try. So if you're taking notes right now, which hopefully you are, you may or may not want to write this part down. Now, if you do, you're going to want to make sure that you understand that what I'm about to write doesn't work. Okay, here's what most students do when this is brand new. They'll subtract 9 on both sides. And then they get this, x squared plus 6x. And they ask the question, what do I know how to do? I see that something factors out on the right side. So they factor out an x, and they get x plus 6. And then they get to here, and they're stuck, which is totally fair. It's really normal that you would be stuck here. So one of the problems is, all along in algebra, what we teach you is, we give you things like this, and we teach you that you can just barge your way through these things with algebra steps. You can do -5 on both sides, and you can divide by 2, and you can get an answer. And until you start getting into more complex equations or more difficult equations, that holds up. I mean, through Algebra 1, through geometry, and through a chunk of algebra, your second year algebra course, that works. However, we reach a point here where we have x in multiple spots, and in a way that they're not like terms, so we can't combine them. So what we get to do, in this example, we're going to try to factor it. Okay, now, if that's new to you, here's what it means. We're going to look for numbers that multiply together to be 9 and add together to be 6. And it turns out that 3 and 3 do that just fine. So 3 times 3 is 9, 3 plus 3 is 6. And then we have to ask ourselves, what number would you plug in here to make that whole chunk say 0? If you plugged in a -3 right there, it'd say -3 plus 3 is 0, times 0 equals 0. That would make it true. Same deal here. Okay, so we've identified our x-intercept. Okay, what about our y-intercept? find the y-intercept. We recall that x needs to equal 0, so y would equal 0 squared plus 6 times 0 plus 9. Simplify that out and you get y equals 9. Now, this shouldn't be super surprising. You may have noticed in this step that another way of writing this is x plus 3 squared. And that jives really nicely with what we learned in the last unit. Now we see we have a quadratic that's been shifted 3 units to the left. Okay, and that's why we're getting those negative 3's in there. Okay, so if we wanted to draw a sketch of this, we'd say, okay, 3 units left. Y-intercept is up at 9. And so I have negative 3 right there, and it's a parabola that goes up and hits there, and we're going to try to make it as symmetrical as possible. So it looks something like that. So wouldn't it be nice if we could just apply this process every time? I mean, the world would be kind of boring, but we'd get it right every time. Sometimes we're going to get examples like this one. So let's see what happens when we try to factor this one. I look for numbers that multiply together to be negative 6 and add together to be negative 3. And if you do a little bit of thinking about that, you'll realize pretty quickly there are no integers that accomplish that. So that little trick that we just talked about doesn't hold up. So what we need is a trick, or a method rather, that'll work every single time. And so there is a method that will work every time. It's called completing the square. And here it is. All you do is you divide by the leading coefficient, isolate the constant term, add 1/2 b quantity squared, and then you factor it out. We're going to do a couple of examples here because it may be really hard to track with this. If you're taking notes, pause the video. You probably want to write this down because we're going to try to track these steps as we go over here. Okay, so I'm actually going to index them on the first one. So number 1, we're supposed to divide by the leading coefficient. Now recall, the coefficients are these numbers, so 2, negative 15, and technically there's a little 1 right there. Okay, and so step 1 is divide by the leading coefficient. The leading coefficient is the one that is associated with the largest exponent, and that's 2, because technically that's an x to the first. So we're supposed to divide by 1. That doesn't do anything. So I'm going to go to step 2, because dividing by 1 doesn't change anything at all. Isolate the constant term. Here's what that means. It means this is the constant down here. I mean, there's no variables with it. We're going to move that to the other side so it's all alone, like this. X squared plus 2x equals 15. Now notice, I left an empty spot here. You don't have to do that, but what that will allow us to do is do steps 2 and 3 at the same time. Because now they want us to add 1/2 b. I'm going to do a little bit of side work. 1/2 b is, maybe we should talk about what b is for just a second. If you remember from the very beginning of the video, we looked at ax squared plus bx plus c. That b right there is what it's talking about, the number or the coefficient that's next to x. So let's go down and pull that off. Down here, that number next to the x is a 2. So that'd be 1/2 times 2 quantity squared. Now if you're not sure what I'm doing, I'm just filling in that right there. Okay, and I'm going to simplify that, and that turns into 1 squared, which is 1. So it asks us to add that to both sides. So I'm going to do plus 1, plus 1. Now if you're like me, you're thinking, what the heck is going on here? Why did we just do that? So this is why it's called completing the square. Because what happens at this point, and I'll work it out on the first one, but then we're going to use the shortcut for the rest. What happens here is it guarantees that you have something that is factorable. So numbers that multiply to be 1 and add to be 2, that's 1 and 1. And it's a little better even than just something that's factorable, because it always guarantees that that thing that's factorable is a perfect square. So you can put it back together like this. Now, the reason that's nice is because now we can go back to using regular algebra steps. I should probably index that as 4. That whole step is 4. All right, and so now we can do things like take the square root of both sides. So x plus 1 equals plus or minus 4. Okay, I've taken the square root on both sides, and then I can do minus 1 on both sides. And then I get x equals plus or minus 4 minus 1. We have to be a little bit careful with that symbol. Okay, here's how we use it. So this turns into x equals 4 minus 1, or x equals negative 4 minus 1. And we're going to compute both of those out. So 4 minus 1 is 3, negative 4 minus 1 is negative 5. we have just found, since that was set equal to 0, we have just found the X intercepts. Now you might say, yeah, Mr. Boyden, we probably could have figured that out by just factoring this in the first place. Yeah, you totally could have, okay? Because we would look for numbers that multiply to be negative 15 and add to be 2, and that looks like that would be plus 5 and x minus 2, or excuse me, 3. So 5 and negative 3. And so what zeros come out of that? The number that would get plugged in there is negative 5. That matches. The number that would get plugged in there to make it equal 0 would be 3. And so that also matches. We've picked a pretty easy example for the first one, so we'd have whole numbers to deal with. They will get more exciting. So let's go to that more exciting one now, the one that actually caused us to think about this method, right here, this example that we couldn't factor. One of the nice things about completing the square is it works every doggone time. It works all the time. So those of you who like to learn a method that works every time instead of some of the time, this is a good method for it, although at the end of the video we will learn a shortcut for it, so stay tuned for that. Okay, so let's complete the square on this one. This would be a really good time for you to pause the video and try it on your own, then start it up again to get some feedback. Okay, here I go. So s squared minus 3s, step 1 was move the constant term to the other side. Okay, then we're going to add 1/2 b. I'm going to do a little bit of side work. 1/2 b squared, that'd be 3/2 squared, and I'm actually going to leave it like that. I'll show you why in just a second. Or excuse me, it was negative 3. Sorry, so I'll put those little negatives in there. Okay, so then I'm going to add negative 3/2 squared to each side. And here's why I'm doing it that way. Because when I leave that as a chunk squared, rather than having to think, how does that factor? I don't have to ask the question because it automatically is just going to come down to these two chunks because it's a perfect square. It will factor like that every time if I leave that unsquared. Now, if I had squared it, it would turn into, well, actually, we'll do it on the right side. It would turn into 9/4. Okay, and there's nothing wrong with 9/4, but the problem is, if I had written it here, it would be a lot harder for me to remember that's supposed to be a minus 3/2 there. So I got to be kind of careful. Okay, let's do some factor arithmetic here, or some fraction arithmetic, excuse me. So I'm going to multiply top and bottom by 4. So I get 24/4 plus 9/4. That's 33/4 equals s minus 3/2 quantity squared. So we're going to square root both sides. And I get s minus 3/2 equals root 33, and I'm going to go like this. See how that 4 was included in the radical? The square root of 4 is 2, so I'm going to leave it like that. Now, I'm going to tell you right now, there's something that I'm missing in this step. This might be a good chance for you to pause the video and see if you've included it, and if you got to this part and you wrote exactly this for this line, see if you can figure out what you missed. The deal is, when you take a square root right here, that produces two solutions, the positive and the negative version. Okay, final step, we're going to add 3/2 to both sides. So I'm going to format it like this. So I'm going to have 3/2 plus or minus the square root of 33/2. Okay, and so now we have found the solutions to this equation, the numbers that make it true. I want you to notice that this is actually two numbers. Okay, we have 3/2 plus root 33/2. That's one of them. The other one is 3/2 minus root 33/2. Okay, so we do have two solutions, just like we showed in the last one. But this one, we're going to leave it in an exact form because I don't have a meaningful way of simplifying that. So let's do another one. Again, this would be a great thing if you would pause the video and try it on your own. This one has one little difference in the beginning. So notice this one actually has a leading coefficient. So step 1, if you recall, is to divide out the leading coefficient. So we're actually going to do that in this one. So we get x squared minus 5/3 x plus 2/3 equals 0. Okay, and then from here, everything's the same. Yeah, I mean, there's fractions to deal with, but everything else works the same way. So we're still going to move this over to the other side, meaning isolate the constant term. So x squared minus 5/3 x equals negative 2/3. Notice I'm leaving that space again. I've been pretty consistent about that, doing it the same way every time. So please do that. Okay, and then I'm going to do that deal on the side, 1/2 b squared. And for whatever reason, it helps me when I write out sort of the format first. pull off b. b is now negative 5/3. So 1/2 times negative 5/3 squared. And looks like that's negative 5/6 squared. Okay, so let's keep going. So negative 5/6 squared. We're going to add, oops, I need a plus sign. And we're going to add it over here as well. And so now it's just time to factor and simplify. So over here, I'm going to factor it. Remember, this always comes down, and that comes down, and it's not the squared version. We're just pulling exactly what it is. So we pull down an x, pull a negative 5/6. Make sure you write that it's squared. Now we get to combine these. So we have negative 2/3 plus 25/36. Looks like we need to multiply on top and bottom right here by 12 to get a common denominator. So let's see what we get. X minus 5/6 quantity squared. And then we get negative 24 plus 25 over 36. So x minus 5/6 quantity squared once again. So we're just kind of working on the right side now. Okay, and I get 1 over 36. I'm out of space, so I'm actually just going to bring this stuff right up here. And now we're going to take a square root of both sides. So I get x minus 5/6 equals plus or minus square root of 1 over 36. We're going to add 5/6 to the other side, and we're going to simplify in one step. So what we get, that 5/6 is coming over, plus or minus square root of 1 is 1, and square root of 6 is 6. So now this is a really good chance for us to practice using that plus minus symbol. So what we get is that x equals 5 plus 1 over 6, or x equals 5 minus 1 over 6. And we'll simplify those out. So this one turns into 6 over 6, or 1. And this one turns into 4 over 6, which is equivalent to 2/3. And those are the two solutions, the two values of x that make this equation true. So I hope you noticed this would have been really challenging to factor, especially since we would have had to have a fraction in the factoring or something like that, or we'd be factoring into 3x and x instead of just x and x. So this is a trick, again, that will work every single time. And we are about to learn a shortcut for it, but again, it's really nice to have tools in the tool bag that work in every quadratic situation instead of ones that just work in some special cases. As you may have noticed by now, completing the square turns into sort of a formulaic process. So when this was first discovered, before very long, I imagine someone said, this feels really formulaic. Do you think there's a formula for this? Maybe there'd be a shortcut way to do it? And so rather than having to go through all the steps every time, they started to look for a shortcut. And so what you can do, you can take this general form. This is what we saw in the very beginning of the video today. And we're going to try to complete the square on this general quadratic where we haven't defined the coefficients and see if we can find a shortcut. This is a really good chance for you to test your skills. I mean, if you can do this one by yourself, it's safe to say you have strong algebra skills. There's no shame in just following along. But as always, I want you to try it first. So here we go. We're just going to follow the process. First, we're going to divide by the leading coefficient. So on the right side, we get 0. But over here, we get x squared plus b over a plus c over a. Oh, and I forgot the x right here. So then we're going to isolate the constant term. So x squared plus b over a x equals negative c over a. We're going to do that 1/2 b squared thing. And this is where it gets a little bit weird because b is actually b over a now. So we get 1/2 b over a squared. And I'm going to simplify that down just a little bit. So that's b over 2a squared. And we're going to add that in. So plus b over 2a plus b over 2a. And from here, we're going to do our factoring. Oh, looks like I forgot to write the squared part. So let's fill that in. Now we can factor. Okay, so I get x plus b over 2a squared equals negative c over a plus b squared over, looks like 2a squared. Now let's get a common denominator. Hey, do you notice the mistake that I made in this step here? It actually is a small mistake. It looks like when I squared right here, I made a little bit of an error. So b squared is b squared, but down here 2 squared is 4, and I think I had written a 2. So let's fix that. So I'm sorry about that. So a squared, and we keep going. So now we're going to get a common denominator over here before we do anything else. So it looks like I need to multiply over here to get a common denominator by 4a on top and bottom. So 4a, and then they both say 4a squared. So what I have is negative 4ac plus b squared divided by 4a squared. All right, so we have x plus b over 2a, quantity squared, and it looks like, so it's the same steps we've been doing all along. Now we get to take a square root on both sides. So we get x plus b over 2a equals the square root, and I'm going to just change the order on this one to save a symbol. So watch this, the b squared will still be positive. B squared minus 4ac divided by 4a squared, and notice this root is encompassing both of them. It is going to be plus or minus that square root. And then final step, as we know by now, we're going to subtract this over, so x is all alone. So I get negative b over 2a, and then we're just going to do a little bit of simplifying. So what we get is we get x equals negative b over 2a plus or minus the square root of b squared minus 4ac. And then notice we actually know how to take the square root of 4, that's 2. So we'll take the square root, notice it's not inside anymore, and the square root of a squared is a. And so this is what's called the quadratic formula. Quadratic formula. Okay, and what it is, it's a shortcut for completing the square. Every time you use it, you are completing the square, but you're doing every single step of the process all at once. So it is a really nice shortcut. Now, how we use it is going to be the focus of the next video. If you were even tracking with this well, or if you were able to do it on your own, you're in really, really good shape. Hope you enjoyed the video. That's all for today. We'll see you next time.